Okay, so here is the lesson portion of today. Writing chemical formulas and naming ionic compounds. Big idea is multivalent metal. If you want to keep this pretty quiet, I'll try and highlight the important things to write and stuff like that. This stuff here, just read it. A multivalent, multi meaning many, many, valent, and we already talked about those. Those are your electrons in outside shell. So if it's a multivalent, it's got different options. It's got multiple electron possible combinations in the outside shell. Um, I believe you looked at these in grade 9. Okay, so Bible page, back of your periodic table. If you look at the top of the page, you are going to see that in this transition metals area, we've got like chromium's got 3 different charge options, manganese, 3 different charge options, iron has 2, cobalt, nickel, copper, zinc only has 1. As soon as we get back into this area, we start to see that these ones tend to listen to what's going on this side, but then you've got these weird ones down here. I think PT is plutonium. Two, I don't know, maybe it's platinum. And then AU, gold, mercury. We've got tin over here and lead. So those are your common ones that are going to have multi-valences. So we've got to figure out, are you bonding with like copper? Are we dealing with copper 1 or copper 2? How do we figure that out? So, in the writing aspect, when scientists were creating their names, they decided to use Roman numerals. And whoops, the daisies. And Roman numerals are just used to tell. Is it the one with the 2 plus ion? We're going to use Roman numeral number 2. Is it the 1 plus ion? We're using Roman numeral number 1. So the Roman numeral tells which charge that copper is. How do you do Roman numerals? I've got them down here. This is probably worth writing out. I would probably throw that into your notes because that's going to be good to reference if you're not very comfortable with Roman numerals. Roman numerals tend to break things up into groups of fives. So they always have a 1, here's a 5, here's a 10. And they base their number system on these different categories. So 1 is just 1 dash, 2 has 2 dashes, and 3 has 3 dashes. And that's how they like actually. So I find numbers 1 to 3 and numbers 6, 7, 8 all kind of follow this pattern where they've got this growing number of dashes. Then we get to 4, and the way 4 is written is 1 before 5. It's a 1 right here before the 5. So that's how 4 is written. And then if you look on the other side of 5, we've got 6's. There's 5. It's 1 after 6. There's 5. It's 2 after 5. Sorry, it's 1 after 5 here. This is 2 after 5. This is 3 after 5. This is 1 before 10. So that's how the Roman numeral system is set up. That's how I think of it. I don't know if that helped you. The most we deal with pretty much in this course, I mean, there is manganese 7. Very rarely do you see a manganese 7 in any of our stuff. Now, I probably say that, and you're going to have one in your homework. Just watch for it. Okay. Um, Maybe go through the example with me, just watch, and then write down some of the examples. Okay? So we'll go through these 2 examples. We know that there's a copper, we know there's a nitrogen. If I go to my Bible page and I look at copper, copper lives right here. I say, okay, it's got 2 options. I have to use a Roman numeral here. I have to be able to say which one it is. So identify the metal, copper. Verify that the metal can form more than 1. We saw it had a copper plus 1 and it had a copper positive 2. So we have to decide which one was used to make up this formula. Determine the ratio of ions in the chemical formula. Well, there's 3 coppers to 1 nitrogen. And nitrogen, if I look back on my Bible page of the periodic table, nitrogen can only have a 3 negative charge. That's the only option. So I have to base my math on that fact. There's one of the nitrogens, and nitrogen can only have a 3 negative charge. So note the charge of the anion. I did that. The positive and the negative charges must balance out. So we had copper, 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 nitrogen, and we knew that was a 3 negative. What did each one of these have to be? And remember, I only have 2 choices, 1 or 2. So it's either 1, 1, 1 or 2, 2, 2. If it's 1, 1, 1, I get an overall positive 3 charge. That would cancel out my negative 3. Life would be good. If it was a 2, 2, 2 charge, I get an overall positive 6, and I only have a negative 3. That does not balance. So that's the thinking that goes into this when you're determining what charge the metal ion had to have. So this is, oh, someone just got into an accident. I'm doing this the morning of today, so it's okay. Copper 1, you have to say it's the 1 charge, nitride. So hit pause and try, if you want to, try this one on your own. Okay, so I'm going to go ahead and do that one. So I've got tin, and tin's options are 2 and 4. So it's either going to be SN2 or SN4. Now, you're not going to have to write this all the time. This is just like our warm-up and we're learning. Determine the ratio of ions in the chemical formula. So there was a zinc, 1 tin to 2 sulfurs. And what do I know about sulfur? Sulfur is a -2. I'm pretty sure sulfur and oxygen, yeah. So my overall negative charge is a -4. And I only had 1 tin. And my options are 2 or 4. It's got to be the 4. Because that would cancel it out. If it was tin 4 to the sulfur 2 negative, 2 negative, whoopsies, that would work. Okay, so then I'm going to say it's the tin 1 before 5, and then this is called sulfide. Whoops, I totally jumped those steps. Whoops daisies. We good. Okay, hit pause, try those. Okay, I'm going. There's a lot of honking happening outside. I know chlorine is, so that's a 2 negative. This has to be a 2 positive. That one iron has to be the positive 2. So this is iron, gotta be the positive 2, chloride. Nickel, nickel, oxygen, oxygen, oxygen. I know this is 2. So my overall is a 6 negative charge. That means this has to be 6 positive. 6 positive divided by 2 is a 3 positive for each. So that would be nickel. Oh no! Megan, spell it right. Ugh. Looks good. Okay. Nickel. 1, 2, 3. Oxide. Okay. Try these. Hit pause. Now I go chromium 3. So that's Chromium is Cr. That's telling me it's 3 positive. Chlorine is a 1 negative. I would need 3 of those to balance out my charges. So this is a Cr, and I need 3 of those. Lead 2, that's Pb2 plus sulfide. Sulfur 2. Those cancel each other out, I'm pretty sure. PBS? Like the television company. And homework time.